Hello, everyone.
Afternoon.
Yeah, so on your screen, I just share with you, right? The SBA dry run, yeah? We're only going to conduct dry run. Just like before with the written test, we have the dry run first. All right, so the actual SBA will be next week, okay? Tuesday as well, right? Around this time also, next week is the actual SBA, right? So the SBA, you will be asked to um, create the what and they will it's basically combine all the um, practicals that you have done, right? And basically you will be creating the topology and setting up the devices lah, right? So as I mentioned before, um, as long as you have done the practical and you know what you're doing, all right, should be no problem because basically it's similar to what we've learned already lah. Okay, so if you have any questions about the practical, so you have to let me know by this week lah, because next week is the test already on Tuesday as well. Now, uh, basically it combines lah. That means before we focus on one part, right? So probably will be combine all the things that you need to do. Now, the thing is, you might know what to do, but there will be a time pressure lah, as usual, right, with tests. So you need to already know what to do. Okay, for example, if you're asked to do create ether channel between two switches, and you're given the details lah, right? So your job is to go into the switch and configure so that the channel is formed, for example, right? So then you must know already if it's a channel, what are the commands that you can type into the switches so to create it. And for another example, maybe continue from there, and then you are asked, right, to provide. Um, maybe you earlier question already asked you. Okay, it's a series of tasks for you to do, right? You must have been asked to create VLAN. So now, further down the questions, you asked to further tasks will ask you to do router on a on a stick. So the thing is, maybe you've done it before, right? But now you just need to complete it within the allocated time. So, like as I gave you hints before, when the strategy to do this SBA is that you already know the contents of all the practical. So you must have your own digital note, right, with the commands, right? With the commands, this is open book, so you are allowed to look at what are commands. The only thing is that the settings will be different lah. The IP address all will be provided in the question, but the command is still the same, right? To set up channel, the command is still the same. It says manually create or use desired use the um, they might ask you to do manually, to create manually the channel, or they might ask you to do um, uh, I think I was talking about trunk link lah. Trunk link, sorry. If the channel is to aggregate the part. So maybe create a trunk link, but they might ask you, okay, do it manually or you use the um, back P or leg P, right? So depending on which one, you know which commands you need to use. So I sincerely ask you guys, have a digital notebook where you have multiple tabs, for example, in text mode. So you have all the commands that you can copy paste into Notepad, adjust all the addressing, and then you can just copy paste inside. So you might be definitely you're going to ask. I don't know the questions, huh? But because it's going to cover your practical, definitely you'll be asked to create VLANs, right? Definitely you're going to be asked to set access ports, trunk ports, create trunk links, right? perhaps also need to create, router and a stick. Yeah. So you if you prepare all the commands beforehand, right? And of course you go back and download any of the practice practical, right? And then you see whether the system works, with the commands there, and how fast you can do it, right? So you categorize what you need to do, right? Not necessarily all will be come out, but maybe most of it will come out, right? Okay. So for STP, it's just understanding. I think STP is automatic, so STP will be understanding the concept of STP. But I think it will cover up to security lah, right? To set up BPDU, port guard, and things like that, right? So basically, you need to prepare yourself. Not only knowing how to do the SBA, but prepare yourself that you can do it within the allocated time. So I think we strategize what is the fastest way you can configure if you are given the configuration task and also configuration details. What is the fastest way you can do it and still do it correctly, right? Because I can tell you, um, it's a bit different when you're doing it, when you have all the time in the world to do it, and when you have to do it in a rush. So you need to have a strategy. Is that okay? Any questions from you guys about this? You still have time until next week, yeah, Tuesday.
Is it just one? They just give us download one packet tracer and then we do the type in our email and then do like that, like the
Yes,
homework.
yes, yeah, just like the practical before. There will be just one. So that means all the tasks that you have done in the practical is separate, right? Separate. But now I think it's going to be combined. They'll ask you to configure this, configure this, configure this. Basic configuration for switch, basic configuration for router, right? Uh, Set the access port, set the trunk link ports, set the router in on a stick. Then I set the EIGRP if they ask you, they give you more than more than one router, two routers, three routers. Then they can ask you to also do the EIGRP. So it's like a step. Yeah, you systematically. I think if I were you guys, I have all the commands for whatever tasks need to be done in my computer. All the instruction, the command, iOS commands, so that I don't have to search for it during that. I know already where it is. I know how to use it. I take it, customize it with the address, attribute, whatever that, because maybe the VLAN's number will be different with VLAN name. So that is the part that you have to, how to say, all the addresses different, right? That means that is the part that you have to customize, and then but the command's still the same. So if you prepare the commands for whichever, then you can do systematically, right? So basically, you provide IP addressing for all the hosts. You provide, you create VLANs, right? You set which port, okay, which port will be access port, which port will be, and practice to do it like like a series of commands in Notepad that you can just copy and paste. You can test it with, you see whether your technique make you do it faster. You can try it out on the past practical. See whether you revisit those practical. See whether if you have prepared all the list and then you just configure in Notepad and copy paste inside is faster, right? This you have to do lah. Yeah, go through lah, right? So at least you have to go through to prepare for the SBA, because the SBA is going to combine all the practicals that you've learned already. Okay, which one will come out? Which one will come out? I think the main topics per week, right? Per chapter that we learn, definitely creating VLANs, creating trunk links, access ports, router on the stick to provide communication, the EIGRP, for ether channel perhaps, because I also don't know what is the what is the specific that they're going to choose. I just to be safe to assume all the topics they will ask, right? And you will see that it's only up to 7:30, 5:15, 7:30, so it's not long, right? 7:30 to 7:45 is again submission time. By that time, you should be finished, and you don't, not to do the last minute things. Aim to finish within that kind of timing. Yeah. So the timing, I wanted to put in earlier on. So let me just double check. Yeah, the SBA timeline is I will publish after we finish today lah, right? Our SBA dry run. Okay, so next week, yeah, as usual you log in at 5, right? 5:05 to 5:10 is a briefing, and then 5:15 you'll start, right? The SBA will be released between 5:10 to 5:15. So we assume 5:15 to start lah, right? 5:15 to start, and then you do the SBA for 2 hours 15 minutes, right? And then that means you should finish by 7:30. 7:30, between 7:31 and 7:45 is your submission time, right? So I guess your practice, okay, to do as fast but as correct as possible, within 2 hours 15 minutes lah, right? So as I mentioned before, the topics all the topics should be, you can do the review homework and also the review practical that we did. That one is a sort of like a combination of all the what you've done, but not the complete one, right? So, but it will be like that. It will ask you to do, okay, do this, but involving all the topics we've covered in the practical. All right. Any question on that?
No.
No. So please on your own, please like I say, prepare the series of commands. You can basically, how do you create it? You go back through our slides. You can also refer to the online net academy. You can see after the theory part of the chapter, then normally you can see the command part, what to do, right? So you also should separate between the configuration and the verification. The show, anything with showing the information is basically for you to troubleshoot if there's a problem, or to just verify that all the settings are done correctly based on the requirements lah, right? So if you have that, a list of commands, iOS commands for whatever tasks need to be done, it make it easier, right? If you come in without all that, and then you're asked, then you have to refer back to during the test, then I'm afraid even 2 hours, it will pass very fast, and you will be in trouble, right? Okay, so this is my advice, how to prepare, how to strategize to take on this SBA, right? Right, because if you notice, if you go online, there's a lot of people, professionals, including students and professionals, right, who go and take the CCNA exam, right? CCNA exam, right? So for CCNA exam, everything is in one. All you've learned throughout the fundamentals, the computer networks and advanced computer network all together, they will ask the question lah. So you have this option when you after you graduate, since you have already learned all the topics, you have this option to go sit for it, to go sit for CCNA to get the CCNA cert. Okay, even if you're not going to do any networking in your career, but it's still a good cert to include in your CV. It can make a difference lah, right? Who knows, the boss of the company see, oh, you got CCNA, so who knows, maybe they include you in the team to propose solution to customer. Then you part of the team, although yes, you develop software, but remember, providing solution, not only the right develop the software, but also to provide the complete solution, including, okay, the network, because maybe they need the complete system. Not they want the software, but without the hardware and the network and all these things, who's going to provide? If you can give the complete solution to them, then they don't have to worry to go different vendor. For example, right? So still very valuable to have this knowledge. All right. So if no question, right? So later on, as you can see, again, I've already invited you guys to our meet. Yeah. So we start at 5 and we'll finish by 6:30, right? So if we finish, I think this one is, again, is a very simple one. So just to give you a feel about, what to do, so that during the actual SBA next week, you already know what to do step by step from the start until the end, right? Again, this is done so that is simplified for you, right? Okay. Uh, Let me I received a message. Sorry, yeah. Uh, okay, never mind. All right. Everybody okay with this timeline for today? The mark obtained pin screen.
Okay.
Yeah, this is, all the SBS got the completion rate. I think this is the one, right? So we'll practice that also. Okay, so we practice this try run today, and then so that next week everybody knows what to do lah. So you can focus on the assessment, answering the assessment itself lah. Right? Okay, so we'll stop this one. Right. So now I want to continue with our task yesterday, which is to look at the. Let me just open up my PowerPoint. Yeah. Right, so mitigating DHCP attacks, that's where we stop. Okay, so before I switch on the recording, I also want to remind you guys that the NetAcad chapter exam, I've already opened, and each of the chapter exam, you can do up to 10 times. It's not the final exam. The final exam is the one that has mark, and that's the one that you can get the cert for. Right? I'm planning to open it next week weekend. Right? So, but I will open it like for the whole weekend lah. So you got time. So even that one, I think you might be able to be given at least 3 times, 3 tries, if you want to improve your marks. Yeah. Okay. So but this chapter exam I open for you is marked by the system, is MCQ. In fact, you normally use this for solidifying your theory knowledge. Yeah. Okay. And some of them may have a question in terms of using packet tracer, so you can try that one as well. Right. Now, I mainly use, for me, I mainly use that. I will use that for revision. Okay, revision on the theory questions, right? So if you do have time between now and next week, okay, just go through them, right? You can do each of the module. Then I allow the system to provide 10 tries lah, right? The question will be every time you try, it will be randomized again. But I do try it because it's just multiple choice question, yeah, ABC. So and it's open book. So you're not sure, you can check, right? You can check the notes or whatever and then to answer. All right. So do try it. I already open. Since we haven't covered the wireless LAN, then that one I haven't opened yet. So after we cover next week, then I will open up the wireless LAN questions as well. Okay. All right. So if you look on your screen, what you see is the where we stopped yesterday. Let me just okay, mitigating Dhcp attacks. Right. Right, so we have two, right? Starvation and spoofing. Don't confuse spoofing and snooping. Spoofing is faking. Snooping is eavesdropping. Okay, snooping, unknown to other parties. You are, eavesdropping into the messages or communication, right? So spoofing is to fake, right? So spoofing attack is the attack. Snooping is a way to protect, okay, by looking into the DHCP messages, basically filtering it, right? So DHCP attack is considered a DOS or denial of service because you're attacking the servers with pretend, okay, pretend to be legitimate requests. So the DHCP server just simply do what it's supposed to do. If it receive a request, it will provide service, yeah. But you overwhelm the DHCP with requests, and also you basically reduce the number, or you just exhaust it. Exhaust means no more available IP address. Remember, the valid IP address within a range for let's say you are using a public private address range. Okay, so you basically minus two, right? The network address and the broadcast address, that leaves you only between 1 to for /24 private address between 1 to 253, right? So it's not a lot, and because it's done in a automatically by software, and done very quickly, you'll see that the available a valid listable IP address, a host IP address will be finished, will be done, gone, exhausted. So there is no more IP address inside the DHCP server to provide to legitimate users, right? So this is the starvation, right? Starvation attack. This here example is using a well-known software called Gobbler. Basically, using Gobbler, create a lot of requests for the IP address from the DHCP. DHCP provide the list, so Gobbler took all the IP addresses. Therefore, the legitimate clients, when they are requesting, there's no more available. So when there's no more available, then they cannot connect. No? They don't have the IP address. Okay, so DHCP starvation attack in this case can be mitigated by using port security, because how Gobbler works is by sending a request message to DHCP using using a unique source MAC address, obviously, right? So if you already use your MAC address in the request and DHCP already service you, because it looks at the MAC address. Okay, for this MAC address, I list this IP address. So already done, right? So if you second time you ask, it will not give you any more. So how Gobbler works is it will change the MAC address for every request that it's sending. So for the DHCP, different MAC address means, oh, okay, so this is a different PC. So I'm going to give this PC IP address, right? In fact, it's possible that the MAC address are fake, or it's a belong to a range that is not part of the LAN, the LAN's proper MAC addresses. Okay, right. So port security means you can limit. Okay, remember we how we set the port security is we limit the MAC address per port. If you say one, right, then only one. But then if you Gobbler send another request of to DHCP, and when the switch check the port and it says that, oh, it's a different MAC address, then what happened? You disable the port, right? Shut down the port. Error state disabled. That's how the port security stops this Gobbler, okay, which is using different type of source MAC address. Is that okay? Is that okay for you guys?
Okay.
Yeah, that's how we stop lah, by just stopping. But the switch doesn't even know whether there's a Gobbler working or not. When the switch, if you set as default only one MAC address allowed for that from that port, then when the subsequent message with a different source MAC address is trying to ingress into that port, then the switch can just stop block, send a message, right? Send an error message, right, or alert message to the syslog server, and then that port is now in error state disabled. Now no traffic already. So that straight away stop there, stop in the stack. So starvation attack actually easy to prevent by just ensuring port security is configured for access port. Okay, access port means the port that is connected to PC, okay, to the host. All right. But there are two, right? So we look at starvation. What about spoofing attacks? Now, spoofing attacks are a little bit more involved, right? So Gobbler, in this case, Gobbler can be configured by the threat actor, right, to use actual interface MAC address, right? So that means not faking any MAC address simply, yeah, right? But it will specify different Ethernet address in the request. So the port security is bypassed because the frame source MAC address correct. We Gobbler clever enough not to change that one because the switch is looking for only one valid MAC address, right? Okay, but so how to fool DHCP? So here, right? In the DHCP payload, the DHCP has a certain format, right? In the request. So in the request, the message for that means the DHCP payload. What's the DHCP will look into the request message. The Gobbler can specify a different MAC address there. Ethernet address basically is a MAC address, right? Because the other one is IP address. That's it, right? So basically, because the switch only look at the frame, the source address, I mean that's correct lah. But the DHCP look into its own payloads. There's an information there, and one of the information is the requesting MAC address. So that means Gobbler provide two different sets of MAC address. The correct MAC address to get through the port, and the other one, the fake one, inside the DHCP payload. So DHCP gets full, not the switch, right? You guys got this part? This is the spoofing attack. Yeah, Kelvin, is that you? You got it?
I got it.
Okay. Noel and Farah, let me know if not.
Yeah.
Okay. So before I move on, I just repeat one more time, last one for this part. Usually the starvation attacks is stopped by port security, because port security you can set default as maybe one only. So if the gobblers try to use multiple MAC address, because the DHCP will check, depending on the MAC address, to allocate the IP address. If I already seen this MAC address, I already allocated, I already list, well, too bad, I'm not going to give you any more, right? So gobbler is going to keep sending requests, but with different MAC address. That's the attack, right? So the DHCP see, oh, it's a different MAC address, so I'm going to list until exhausted. Then starvation, right? Then we say, okay, we stop it by the setting the port security only one MAC address, right? Oh, that's work, because now gobbler cannot simply use a different MAC address, because if you use a different MAC address based on the port security, the switch can stop the port, disable the port, detect that the more than one MAC address is being used. Then gobbler can use another technique. Okay, for the frame header, the source address MAC address is still the same, right? So it will get through the port security because no change, right? It's the same. So for the switch point of view, yeah, okay, this is valid. This is the MAC address. Okay, but DHCP look into the DHCP payload, and DHCP will not look at that. They will look at the MAC address that is the requesting MAC address in the DHCP payload, means the PDU of the DHCP, right? And that's where gobbler can put in multiple or different MAC address. So of course it shouldn't be different, right? It should match the MAC address, source address, and the frame header, and inside the DHCP payload should match, right? But this is what the gobbler software can do. It's just varied, okay? Provide varying MAC addresses in the DHCP payload to fool the DHCP, but yet use the correct MAC address at the frame header to bypass or to get through the port security. So how do we stop this one, right? So this we have to do some snooping. We have to go and look inside the DHCP payload, right? So DHCP spoofing attack, which is this one, can be mitigated by DHCP snooping, right? Right. So again, we do filtering, right? We don't look at all frames PDU, but we only look at the DHCP one, right? Because it's specific to DHCP attack. So DHCP snooping filter the DHCP messages, right? And then will red limit DHCP traffic on untrusted port. Now we have to specify first. We have to define what is untrusted port, right? So how to know what is untrusted port? We look at what is a trusted port. Trusted ports are ports considered to be under administrative control. Means you can if you want to go and configure those ports, right? That means you as a system admin, you can put security like a password and all this, right? For those devices like switch and routers. So any devices that not plug and play, those that has iOS inside, you can configure security there, right? So usually switches, routers, and servers got security, right? So these are trusted sources, right? So that means cannot be that switches, routers, and servers are hosting threat actors, right? Because we configure, we are the ones that's configuring these devices. So we are the one responsible for the security for these devices. Meaning we set the password, we set the encryption, we set whatever security. For example, switches and routers. Okay. Manually, physically, we can put it in a secure room, we lock. And to access it remotely, we have all the password encryption and all these things. Servers the same. So these are trusted sources. Because in order for a threat actor to manually access this to do something from originating from these devices, they need to have physical access. And by physical access, meaning you have to break the lock and things like that, right? So we consider those devices under administrative control as trusted sources. Trusted interfaces are interfaces on trusted devices, right? Like trunk links, server ports, all this, because these ports are again very difficult for the threat actor to gain access if it's physically locked. Okay, so this trusted interface within switch on the trusted devices like switches, routers, and servers. Now, now once we know what is trusted, I think the rest are untrusted because they are open, right? So hosts, for example, hosts, right? Hosts in any workstation, they are, yes, maybe your office, you said, oh, our office, we can, but because we don't only think about these threat actors as outsiders. Insiders also can be threat actors, correct or not? So these devices that is not under lock and key, where it's potentially accessible to everyone, even the people in the department, in the office, whatever, can access, right? So these are considered untrusted sources. So when we say we're performing this dhcp snooping, we actually doing this only mostly on untrusted ports coming from ports with links that come from untrusted devices, right? So you can see devices outside the network and all access ports connecting, not servers, but workstations that are connecting to hosts. These we should treat as untrusted sources, right? Okay, so rate limit means we want to reduce the DHCP traffic. We want to ensure, because once the DHCP sending messages out, to be honest, per device, you shouldn't have within a period of time. Even if your list, nobody will set the list for 1 second, 2 seconds, 3 seconds, even 1 minute, right? So if you detect a pattern where when you snoop, oh, it's DHCP message, but how come this DHCP is practically streaming coming out from this particular workstation? Something is wrong, lah. It's not the normal operation, right? Because usually when you request, you got IP address and you're satisfied. You're not going to request again from the same device, right? So what we do snooping is to find out whether what is this messages. Is this DHCP? Yes. Okay. Within a certain period of time, right? We do not allow more than a certain number of DHCP requests, for example, right? And it's okay because in general, the way networking works, once you get a list of IP address, you're not going to ask again until the list expired. Then you request, right? So rate limit means within a specific time period, you're not allowing more than a certain number of DHCP traffic from a particular untrusted port. Okay? So far, okay?
Okay.
Okay.
Yeah? So that's how you stop, because we use the logic of the DHCP operation. Okay? So DHCP basically like, for example, imagine if you're using a computer, right? You switch on your computer will want to use IP address. So your computer sends out a DHCP request. Usually, very quickly, the DHCP reply you with a valid IP address, and you configure your IP address, and you can communicate. That's how normal operation works. And your IP normally is valid for the least time. Okay, LEASE. The least is a word they use to indicate how long the IP address is assigned to your particular machine by the DHCP server. So that's the normal operation. What is not normal is your computer send request, and very briefly after that send another request. Remember, the port security cannot detect because you still use the correct MAC address. Okay, so how to stop? Well, rate limit for DHCP messages coming up from untrusted port. Don't allow more than a certain number. You limit the rate of DHCP messages coming from untrusted port. All right, so in this part, it was basically describing how the DHCP table, the desync table, is created lah. Right. So again, source MAC address, okay, detected from the DHCP request by the DHCP server, right? And then that is the unique identifier for the DHCP server to know whether an IP address has been leased to that particular machine with that source MAC address, right? So once the list is given and acknowledged by the server and accepted by the host, the MAC address, gotten from the source MAC address inside the DHCP request message will be bind together for as long as the list is not expired, right? So the binding is between the MAC address of the requesting PC and the IP address that is being leased to that PC, right? Right. So this table is then called the DHCP snooping binding table. Means you can then see, right, MAC address and IP address bound together, right? So how to implement DHCP snooping? Right, so on the switch, you enable DHCP snooping by using IP DHCP snooping. Right, this is global config. So config terminal, and then you can type this already. Right, it's inside global configuration. Global configuration simply means in your switch you type enable, and then once you're in privilege mode, type configure terminal, then you're in global configuration. Right. Of course, from there, if you want to go to configure specific interface, specific things, then you can go in deeper. But config terminal, then you're in global configuration. So you type this command IP DHCP snooping to enable the DHCP snooping, right? So for trusted ports, you yourself know what is trusted ports are. Use this command IP DHCP snooping trust interface configuration command. You will need to go after global configuration. You need to go into specific interface to configure, right? And when you're inside the interface, let's say fast Ethernet 1, right? You're inside the interface already, the config interface. Then you type for that interface IP DHCP snooping trust. So you trust it lah, right? That means the snooping will not work on the trust because no need, because we trust the port, right? On untrusted interface, limit the number of DHCP discovery that can be received by IP DHCP snooping limit rate. Okay, so then you can specify what is the limiting rate lah. How many how many DHCP messages are passing through the interface per second. So this one again, you identify which one is the access. Usually it's access port lah, kan? Those is connected to host. So for those interface on the switch, you enter the interface and type this command to limit the rate, right? Okay, so, for DHCP snooping by VLAN or by range of VLANs, use IP DHCP snooping and the VLAN, right? Right. Again, this is global configuration command. So let's look at an example. Okay, so inside this switch, global configuration, you enable first snooping, yeah, IP DHCP snooping. Then you go into specific interface configuration. So here is fast Ethernet 1, this side. So this side is trusted because it's going to the DHCP server. This side is untrusted, right? Because it's going to host. Okay, usually going to host is untrusted lah, as I mentioned before. It's not under lock and key, so anybody can, go and use this machine. Whereas this one is usually under lock and key. A data center, or you normally put your server not in open but inside lock room. So we trust this one lah. There's not going to be any threat actor using this host to attack the network, right? Right. So yeah, once you're inside that interface, you enable IP DHCP snooping trust, because this part is trusted, right? Then exit and go into the second interface, which is F05. In this case, the rest of the ports we indicate, because you're the system admin, you know which ports are going to connect to host machines, host devices that is untrusted. So in this case, between the range of port 5 up to 24, all untrusted. So you go in there. Okay, so that means whatever you type here will operate on this range of ports. Then you type lah, right? IP DHCP snooping, limit the rate to 6 packets per second, right? And then exit again. Then you want to enable IP DHCP snooping on VLAN 5, 10, and the range between 50 to 52. So 50, 51, 52, and then finish. Then that means you have configured so that to prevent DHCP spoofing, right? Spoofing. This is for spoofing. Okay. The Starvation enable the port security, for the MAC address. Okay.
So can go to the previous slide.
This one?
Yeah. So step 2 cannot be done without the step 1.
Yeah. You have to enable basically the step 1 is telling the DHCP that you want to enable DHCP snooping, right? So then the step 2, is configuring the trusted ports. Step 3 is configuring the untrusted ports, right?
Oh.
Because after you enable, then you have to configure the ports. Yeah. So if you just configure the ports, but then it's not enabled, you haven't done step 1, means it's not enabled yet. So even you configure step 2 and 3, it doesn't work because you haven't told the switch that you want to enable DHCP snooping. So the step 1 is to let the switch know, okay, I want to activate for you to run this DHCP snooping. Okay, and then step 2 and 3 is required, because then you need to tell the switch which port is trusted and which port not trusted. For the port not trusted, what is the limiting rate? Okay, because this snooping is snoop into frames and see the PDU. If the PDU is a DHCP PDU, then filter. Means if it's on untrusted, then apply the limiting rate for that particular port. So this is done for any ingress frames, frame ingressing through ports. So on trusted port, they don't have to do any limiting, no limiting, no checking for how many DHCP packet passing through that port. For untrusted, you set the limit rate. So this DHCP snooping service will check any frames ingress from that port, those untrusted port that you set the limit rate, and will start counting right? So if it go beyond the number of DHCP message within a specific period, which is I think is per second, right? Per second, then it will block it It will drop it. I don't think because it's only on DHCP, it will just block for the DHCP, not for any other PDUs.
Then the other ports, if the other ports you don't configure, are they trusted or untrusted?
I don't know what's the default. It doesn't say. I
Or
think by default, because there is no, let's see further, see whether there is any mention on any defaults. No mention on defaults, huh? Yeah, correct. If we don't specify what will be the default, you're talking about the default value, right? Whether the default is trusted or untrusted.
yeah.
Yeah. Now this one not mentioned here, we can check lah. I can check for you. Okay, let me just check very quickly. Okay, let's just say that by default, Dhcp snooping is not active. Uh, wait, what's the default? Huh? Uh,
Is there a command to check the
yeah, the next slide actually is the to provide the yeah, right. But what is the default if you don't set? I'm not sure. No, but no. The literature also don't say which one is. Hang on,
So this only show the ones that you already set lah. Just
yeah,
not the ones you
yeah.
don't.
So I'm not sure what is up. Maybe what you can do if you enable it inside your packet tracer and see what's the if you check show IP DHCP snooping, whether it's trusted yes or no by default. Because normally you already configured, right? But if you don't configure, and we can try. So I think that's the best way, right? I think that's the best way to find out what is the what is the packet tracer tell us. Of course, we can we if we test this on the real switch, then that will be the definitive answer. Since we don't have a real switch, then maybe you can do it on the packet tracer and see what's.
Is it the packet tracer different from the real switch? Sometimes the default.
There are certain commands available in the real router or switch that is not available in the packet tracer version, right? Either they cannot implement or they don't implement that one lah. Because I remember reading some part of the what command before. Hang on, let me just right. So let me log in. Let's see. All right, so I'm just gonna take any oh, not router. Sorry. any switch. 2960 lah. Go in, click. Right. So to enable is IP DHCP. What was it command? IP DHCP Snooping, right? To enable. So let's see. Right, so let me just share my screen with you. This one. Right. So okay, so this one I'm already in, right? I'm inside the switch. So the type IP DHCP Snooping. Oh, config terminal first, and then IP DHCP Snooping. And so now we show IP DHCP Snooping. Oh, okay, not in the config, sorry. Exit first, N first. So, so IP DHCP Snooping. No configuration at all. Can't even see whether which interface is yes or no. Okay, can't tell. Undefined. So that means it's as if the snooping is not enabled at all. No trusted, not untrusted.
Just
That means the snooping
cannot access them.
yeah, the snooping is not triggered lah. It's as if you haven't done any you haven't done this command lah, this one. It means it's incomplete, so it's not turned on yet. It's enabled, but you need to complete by configuring which one is trusted, which one is untrusted, in order for it to work. So if you just enable like this, it's as if nothing here means it's as if it's not active. Huh?
If there's a
it's not doing anything.
The port is not activated on here.
Yeah.
But
yeah.
still will it still be vulnerable if the
yes, still vulnerable.
If so, because every interface need to do the trusted, not trusted.
Yeah.
Then can be secure.
Yes.
Oh, okay.
That's why they give you the option to do by range to make it easier. To make it easier for you as a system admin. Okay, coming back to here. All right. Right. So we're here again. Yeah, you can see here if you compare just now with this one. Once you start configuring, then I think the DHCP snooping will start working. If you haven't selected which is trusted, which one is not, set and then setting all the ports, then those ports you ignore to set will be unsafe unsafe from DHCP snooping. This one only check for DHCP snooping, right? So let me ask you guys, if I forgot to set the port security by enabling DHCP snooping, will it stop the starvation attack?
Sorry, what again?
Because for the starvation attack, right, we stop by using port security. If we don't set the port security, but we enable DHCP snooping, will it stop the starvation attack?
I think no.
No, huh?
Yeah, I think also no.
No. Because you red limit DHCP messages coming from untrusted port. So that means if you still use Gobbler to do the normal attack just by varying the source MAC address in the frame header, but you still need to send many requests, right? So it still will stop in terms of rate limit, right? But of course, you have to enable just in case, right? Your rate limit is the way they can set the Gobbler to send in the Dhcp reply just above the rate limit and just below the rate limit. So 6 packets per second limited to, right? But what if I put a timer, I send in 1 request per second? Then it will pass through here, right? So that means if we did not set the port security, then you can still do the how to say this, the starvation attack. In fact, this is also starvation. The spoofing is also starvation. You want to get all the IP list. Okay, so you need to set both, because if not, this one rate limit is, let's say, 6 packets per second. What if I send 1 packet per second? Or 4 packets per second? Still get through, right? Right? It gets through my rate limit. Yeah, it's slower attack, but I can still do it. So, but with the port security, you basically stop the normal frame header attack. Okay, Dhcp frame header, source MAC address. But here, if I send in 4 packets per second, will it bypass? Will it go through?
Not sure.
Because it's up to it's limit to 6. The rate limit is 6 packets per second. 6 Dhcp packet, right? In order for a Dhcp packet to complete the DORA, how many communication needs to happen?
4.
4, kan? So whatever it is, 4 that means 1 request per second in order to complete request until acknowledge, about 4 packets. So it's should be very fast, right? So I'm just thinking, can we defeat this by just going just below the rate limit? 6 packets per second. So if we send our request one request per second, then we are within the limit, right?
Yeah.
It's a bit slower, but we still managed to request. Okay, so I'm not sure whether this is testable or not. I'm not sure whether we have Gobbler to download. We can test it. We can easily test it. You can run a Dhcp. Sorry.
So forgot to record.
Oh yeah. Sorry about that. Let me start recording. Excuse me. Yeah. think there is a very easy to download. I think this is one of it. What you can do is you can test lah. We don't have the switch. If we have the switch, a real outway switch, then we can try. But you can also use packet tracer and see. But we cannot run Gobbler from packet trace in the packet tracer, right? If you have the real switch, you can download Gobbler, and we can try to attack our switch, our DHCP server, right? We have two PCs, both connect to the same switch. We enable rate limiter on the switch pretending to be a threat actor, the other switch pretending to be the other port belonging to the PC, which we set as server lah. We install our DHCP server there, and then we can just run Gobbler from this side and then try to test this rate limiting, right? I think Gobbler can be configured to slow down the attack. Okay, so I'm not sure. Okay, if the threat actor can limit their attack to below six or below packet per second, what happened? Will it be still considered as attack? Right? What do you guys think?
I think it will reduce a bit.
It will block. Reduce the number of DHCP.
Yeah, reduce. I think it will reduce the DHCP.
The DHCP messages. How about you, Noel?
Not sure. I still don't know the concept, the packets per second.
Rate limits. It will, limit the number of DHCP messages, right? That can flow through that port within a second. That means how many DHCP packets allowed to pass through that port? Okay, within a second lah. In a second. Right?
So if a second already pass through already, so it reset the number.
Reset the number. I think. Hang on. Let me just check what happened when the rate limit go beyond the rate limit. Yeah, so if it goes beyond the rate limit, that means if more than, let's say we put 6 packets, if it's beyond 6 packets, those packets will be simply blocked, and there will be a system audit message going to syslog again. Right?
Or DHCP occurs in various end device, right?
Sorry?
End device, I mean several end device to send DHCP to the server, right? Not just only one end device.
This work based on the port, based on the individual port. So the switch is able to check individually the port, right? You can set the rate limit different for every port, but usually you want to secure the untrusted port, you give a range and then you can set the limit, and then the switch keep checking on all these untrusted port that you set the red limit on. So if there's more than 6, right? 6 in let's say like this configuration, like more than 6 packets in a second, the extra packets will be dropped, and then the admin will be alerted because the syslog will have logged Dhcp snooping error on which port. Okay, but my question is, what if you try to do the snooping, and no, not snooping, the spoofing, but within the red limit? Because it's checked per second. So if you're 6 and below per second, but you're doing the spoofing also. Sorry, not spoofing, spoofing. So will this prohibit, or will this work to stop the attacker?
Oh yeah, I think no.
No, right? Because you're already spoofing, so it doesn't matter whether port security is enabled or not. And then and because it's at the red limit for that port, that means you are doing it slowly lah. The threat actor is doing the spoofing attack slowly, staying within the red limit of the port, right? So it's still able to attack lah, but it's a slow attack rather than that. Because normally you can exhaust the list very, very quickly lah. For this one, that means other legitimate users can still complete. So you can very quickly. So if you are able to send only 1 or 2 requests per second, then to exhaust all 243, let's say 243 IP, you just multiply it, right? So it takes you about few minutes, I guess, slow snooping attack. And in the meantime, other legitimate PCs can have also send their requests. They already got the IP address, so your DOS is not really that critical. The attack will not be as critical as if you don't have red limit. Without red limit, within a second, you probably already exhaust. Not within a second. Few seconds, you already exhaust because there's no red limiter, right? So my assumption is you can still attack, but your stack is not as serious because you have to slow down the attack. All right. Okay. Now I will check further about this one because I just thought about it. Right. The next section is how to mitigate ARP attacks. So just a quick recall about ARP, Address Resolution Protocol. We know ARP is needed because we have ARP cache in our computer. Every computer will have ARP cache because our ARP table or cache contain the mapping between IP address and MAC address. Okay. Typically, when our app want to send a message to another app on another computer in the same LAN, right? Even though we know the IP address of the destination computer, what the switch required is actually the destination MAC address. Since we don't have the destination MAC address, we cannot complete to create the frame. So when that happens, that means the destination host that we want to message, okay, we only have the IP, we don't have the MAC address entry in our MAC in our ARP table. Then we need to send the ARP requests. ARP requests will be broadcasted, okay, by the switch, because we're going to put the destination as broadcast because we don't know the destination MAC address, right? So the destination PC will reply, and from that reply, we can know the destination PC MAC address, and then they can then insert it into our destination MAC address in our frame, then we can send our message. And that mapping is now stored inside our ARP cache. For next time, we don't have to send ARP broadcast anymore. We can just look into our ARP table. Now, how is this protocol or this service being used by a threat actor, right? So the threat actor can send unsolicited ARP replies. What does it mean, unsolicited? Means there is no PC sending the ARP request. Usually, computer will reply. The computer that receive ARP broadcast will reply the ARP request. But here, the threat actor sends unsolicited ARP reply. So even though the threat actor machine did not receive any ARP request, is still sending it. It's unsolicited. Nobody asked for it. No host asked for it. Okay, so that means forcibly sending reply, okay, to other hosts, right? So of course the threat actor will put the threat actor's MAC address, okay, in the unsolicited ARP replies. Okay. Okay. So the MAC address of threat actor and the IP address of the default gateway to prevent ARP spoofing and resulting ARP poisoning. Spoofing, basically faking the MAC address of some other legitimate computer. Okay, so that the other host, instead of having the MAC address of the real legitimate host, they have the mapping of the threat actor's MAC address and the IP address, right? Because you already spoof the other machine's MAC address, right? So spoofing and ARP poisoning, basically poisoning is putting in invalid MAC address, IP address, entries into other hosts ARP table, which means you can't trust your ARP table already. It's already been poisoned, right? It fills filled up with fake or wrong MAC address and IP address mapping, right? The ARP poisoning. So how to prevent this? That means the switch need to ensure only valid ARP requests and replies are forwarded by the switch. Okay. So we have the dynamic ARP inspection. Again, we inspect the content of the ARP messages. Okay, and this dynamic ARP or inspection or DAI requires Dhcp snooping, okay, to be enabled, and then it will help prevent these ARP attacks by not relaying invalid or gratuitous ARP replies out to other ports in the same VLAN. I mean, same VLAN, basically, if you don't implement VLAN in your network, okay, so basically just one VLAN, right? But if you implement VLAN, then this dynamic ARP inspection works per VLAN, right? Per VLAN, right? Intercepting all ARP requests and replies on untrusted port. That means it's filtering. If the ARP request and replies is coming from untrusted ports, then it will intercept. It will check it. Okay. So verifying the intercepted packet for valid IP to MAC binding. Is it correct or not? Is this incorrect IP to MAC binding or not? Right. So once it detects it's invalid, it will then drop those ARP requests. Remember, ARP requests could be unsolicited, means there was no corresponding request ARP message. Right? So how you know whether it's unsolicited? Because there is no corresponding request ARP. Okay, because the threat actor is sending unsolicited means there's no corresponding ARP request. Okay, just the threat actor just send this ARP replies anyhow, right? So that will be invalid ARP replies, no? Because there's no corresponding ARP request. Nobody asked for it, but then the threat actor is still sending a reply. Okay, so what happens is those ARP replies, okay, will be dropped, and of course against this log, server will receive a log. Okay, the log is useful for the system administrator to see whether there's any case of ARP attack lah, right? To prevent ARP poisoning means the ARP table is still correct for all the hosts. Okay, once the ARP table contain misconfigured of invalid IP to MAC binding, then that table considered poison already, right? That's why we call it ARP poisoning, right? So if you detect the invalid ARP replies, okay, to go beyond a certain configured number value, then you can also set it to disable that interface. Okay, of course, again, logging, and then error disabling that interface, right? Right, so DAI, the implementation guideline, enable Dhcp snooping. So basically you get two for one lah, right? You also, when you enable Dhcp snooping, then it'll check ARP at the same time, I think, yeah. So enable Dhcp snooping globally. You also enable for VLANs, if you have VLANs configured, for those VLANs that use for data traffic, okay? If you're doing it for VLAN that is secure, VLAN that is and also VLAN that is not really used for any traffic, like parking lot, or then maybe you don't have to do snooping for that one lah, right? And I believe also for administrative VLAN, because administrative VLAN administrator usually fix their IP address. They don't use a DHCP, okay, on the administrative machine lah. Okay, so enabling DAI on selected VLANs, and then configure in what are the trusted interface for both DHCP and ARP inspection. Okay. All right. So I think this one we already mentioned. Trusted port. Okay, trusted port and untrusted port. So all access ports should be untrusted, and all trunk ports, okay, or uplink ports, we connect to other devices that is trusted, which should be trusted lah. Okay, usually how we configure, although the topology looks like this, as I mentioned before, our switches and routers usually we put them accessibility, manual accessibility to these switches and routers are not available to normal people. Again, we use the lock. Yeah, we lock it inside a cabinet, inside the server room, even the switches. Yeah, so we do trust. That means no remotely, we protect it remotely by using encryption and password, right? So remotely, we already know that very difficult for threat actors to access, to configure. So physically going into here to unplug and plug also manually already deter the threat actor by locking it, locking the devices. So we consider those as trusted, but here we cannot really, because this is open to not considered only public, also privately to your employees, but we also consider this accessible hosts as potential threat actor can use. So any access port should be untrusted. Right? So here is how we configure. After you type IP Dhcp snooping, and then you type IP ARP inspection. Right? So here we configuring for VLAN 10. We allow for VLAN 10. Here we configure for interface. Right? So we can do both lah. So I think if you want to set more than one VLAN, I just normal separation or range lah. You can use range, but normally we put comma and then other VLAN number. We want to enable the snooping for VLANs, also IP IRP. So you can when you set security, you can do for both lah, DHCP and ARP at the same time, right? All right, so DI can also be configured to check for destination or source MAC and IP address. For destination MAC, it checks the destination MAC address in the Ethernet header against the target MAC address in the ARP body. So that means you can try to match it, right? Source MAC, check the source MAC address in the Ethernet header against the sender MAC address in the ARP. So that means if there's the different not matching, then that's invalid. Invalid ARP message. Remember, I tried to spoof ARP means you have to use some other host MAC address, but your MAC address still your own MAC address, right? So that means there's a disconnect between the ARP reply Ethernet sender MAC address and the actual Ethernet frame sender MAC address. So if they're not the same, that means something is wrong. Something is wrong with the ARP reply. Okay. So also check for invalid or unexpected IP address, not valid, right? Not valid to be used. Like this one is localhost. This is, sorry, not localhost. This is unknown, right? For network, this is a network address. This is not used at all. And this one is basically broadcast, okay? Broadcast address. So of course, not ARP is work with unicast, okay? Unicast messages, not for broadcast and network. And then IP multicast also not allowed, because MAC address supposed to be for per host, not multi-host. So multicast IP addresses shouldn't be used. So this is a misconfiguration already. So sometimes threat actor can use misconfigured addresses to do some invalid things. Maybe something that can confuse the switch, right? But you can block this kind of addresses when you detect it. Okay. All right. So I think this one is to check. So IP ARP inspection validate source MAC, destination MAC, and IP. Right. Do not show run include validate, and then you can see that it will perform validation for IP, right? And source MAC and destination MAC, right? Okay, so after you configure this one, right, then your switch will check for this validity of the IP addresses, right? I wonder whether this okay, let me just stop for a while. Just want to Alright. Okay. Because just now I think the animation didn't work. So this is the messages behind, or it becomes too big, cannot fit into here, right? So I just you have to click, right? Okay, so this is the command just now, IP ARP inspection validate, and you can put in source MAC, destination MAC address, and IP, right? So to check, to validate these three, okay, optional, you can set one or two or all three, yeah? Okay, so what happens if it's invalid, as mentioned in the previous section, then the ARP packets will be dropped, all right? Yeah, so there's no matching. That means if not matching inside the ARP packet and the real frame, there's something wrong already. It should be matching, right? So when a host send a reply, the content of the ARP packet specifying the sender, it should be the same as the inside the ARP packets should be the same as the one in the Ethernet header. If not the same, then something is wrong. Or if you check inside the ARP message, okay, the body of the ARP message itself, not the frame header, that you see something like this addresses IP multi-class or using not unicast address right? Then something is wrong also. So drop those ARP packet, right? All right. So this is the command to set and to check Okay. All right. Any questions on the ARP? Very similar to the DHCP, but for ARP, you basically check the content, to check the validity of the MAC address and the IP address.
So we just put in the range of valid IP address.
No, this one the ARP inspection will check it, for you, right?
Oh,
As long as it's not unicast, you start to you can see the address that is invalid, right? Multicast, because you remember ARP is being used for unicast, because you want to send unicast message, right? So you're expecting the valid host, destination host to reply to the ARP request. So that means only from one computer will match the IP address. Okay, so that computer is going to reply with their MAC address. But when you start seeing multicast address or broadcast address or other invalid unicast address, then something is wrong already, right? Another thing that for that one is for IP address. For this MAC address, you compare both destination and source MAC from inside the ARP body and the real in the header, the frame header. Okay, so destination MAC in the frame header and the destination MAC in the ARP body. If it doesn't match, something is wrong. And the same with the source MAC address. It should match, right? So if they detect any of this misconfiguration or purposely because threat actor wants to do something, then the ARP packet will be dropped, right? You don't have to put in the valid IP address. The ARP inspector within the switch will check. Okay. So validity of the source MAC, destination MAC is whether it match or not, because you see how the attack works. The attack works is that one is unsolicited, right? Then it's trying to spoof other ARP MAC. Okay. imagine this: you want you have the IP address, you want to send the packet to that correct destination, but you don't have the MAC address. Then the switch needs the MAC address, so you send ARP, right? Send ARP, so that when you receive back the reply, then you can update your ARP table where it contains the MAC address and the IP address mapping, right? So what happens if you receive an unsolicited ARP packet? You will also, because there's no state, there is no, from the sender point of view, the sender don't need to keep track. Oh, did I send a ARP request? I don't. If I send, then I should receive. Or it's not expecting something like, hey, I received a reply. Did I send any requests? It doesn't have that kind of state checking. So if you receive the ARP reply, it will use that info to update its MAC table. And when its MAC table is updated, then the ARP table is poisoned already. Right? So it's like your glass full of water, then you drip one poison, the whole water is poisoned. So poison IRP table means you have an invalid entry already inside. So you want to stop it before it reach the host. So the best place is the switch. The switch, as it receives the ARP packet, it would perform the checking for the source MAC address and destination MAC address, and also whether the IP address specified is valid. If it's not, any of it is not valid, then it will drop it, thereby preventing ARP table from being poisoned, okay, for any of the hosts that it was intended for. Is that okay?
Okay.
No? Yeah. How about Farah and Kelvin?
Okay.
Okay.
Okay. Right. So mitigating STP attacks. STP is for preventing loop, but providing redundancy path, right? Alternate path in your network, but you don't want a loop. Okay. The thing is, how does STP work? The protocol work is that we have election. Election happens automatically between the switches. Okay, and based on last time we learned, based on the BID, right? Okay, the BID, and then there's a tie break until the tiebreaker. The last tiebreaker is the MAC address. The lower will win, right? So the thing is, how do we bias from the point of view of the system admin? How do we bias the STP? Well, if we want a particular switch to be the root bridge, then we have to set the priority for that root bridge to win. So the attacks works the same way, right? So as a threat actor, just want his machine to be the winner. So participate in the election and win the election, then everyone will, all the switches will forward to the root bridge. All right. So that's the attack, STP attack, to affect the election, right, or to bias the election, so the threat actor's machine become the root bridge, right? Okay, so how to mitigate? Right, you can see spoofing the root bridge, and by when you change the root bridge, the change you also be able to change the topology by, because when the root bridge change, all the recalculation for the root port and all this will change, so the topology will change. That means which port will be blocked will change also, right? So to mitigate, enable port fast and BPDU guard, right? Port fast immediately brings a port to forwarding state from a blocking state. So that means there's no listening and learning. What does it mean? So one thing, you connect faster. Okay, if you switch on your computer, you connect faster because port fast is on access port, right? You connect faster because you don't need to deal with any BPDU. BPDU is packet, I think, yeah, right? Then at the same time, you are not able to send BPDU messages will not be accepted from your machine. So if I'm a track actor, I'm trying to send the port is port fast, so it's not going to include that port as a port to receive the BPDU, right? The that BPDU got information about the election, right? So if the port is blocked on the BPDU, that means it's not going to participate. Your host cannot participate. That means the track actor cannot participate. Remember, the attack is that the track actor's PC tried to fake a switch, right? Because it's sending out BPDU, right? Okay. Now the port fast basically don't disallow any BPDU packets coming from a host. Okay. The second one, BPDU guard, is to what happens if the threat actor still send a BPDU packet, then it will be detected and immediately disable the port, error disable the port, and then send a log message to the syslog server, right? Okay, so work in combination. Okay, so immediately you stop the attack on the STP because our switches are trusted. Normally, we don't leave our switches, infrastructure device out in the open. We lock it, right? And we stop threat actor's machine, the host, okay, to fake as a switch because we don't allow BPDU. We block the port for BPDU. We block here, right? We block BPDU here, become port fast, no longer doing any, the port no longer listening and learning about the, receiving any BPDU, right? BPDU guard is, if it does still receive, then it will lock immediately because it's not supposed to, your machine not supposed to send any BPDU, right? And if you do send, this BPDU guard will immediately error disable that port, and then a message will be sent to the syslog, and then usually the admin, right, administrator will be notified, the log. Okay, you can actually attach a syslog server. You can actually attach like notifier, event forwarder. Suddenly your app can on your phone will just come out and provide alarm. Okay, you can configure all these sort of things to be alerted, right? So configuring the port fast, select the interface, which is the interface connecting to that host device, and then change the port to become mode access port, switch port mode access, right? And then specify that spanning tree port fast, right? And then okay. So this one is for each interface. This one, the spanning tree port fast default means it enable port fast on all interfaces, right? So this is first command tree port fast is you selectively enable port fast on interface. Okay, right? That means you for this interface connecting to another switch or router, you switch mode trunk. And then for those interface facing to host, selectively, each one by one, or interface range, then you can spanning tree port fast. The second method here, spanning tree port fast default, means you set all ports to be port fast, and then you selectively choose to set switch port mode trunk to selective interface. So it's either way lah you can do, right? So far okay on this. You don't have to do both. You do this way. Okay, hang on. Let me just highlight. You can do this way, or you can do this way. This first way, you enable switch port mode trunk on all ports going to other switches or routers, but selectively you already know which ones connect to host, right? For those interface, you selectively configure port fast. Okay, or you can do this way. Okay, you do it this way, spanning tree port fast default, you enable port fast on all ports. Then selectively you go to ports that connect to other switches or routers, selectively enable the trunk, okay, mode trunk on them, right? And then to verify configuration, just type show running config begin span or show spanning tree summary. Then you can see, yeah. All right, so the other type is BPDU, right? BPDU alerts allow the what to be alerted. Let me just okay, I'm just going to here. Okay, right. So BPDU guard, as I mentioned before, just to detect whether there's a BPDU received at that particular port, which is not supposed to be, then it will disable the port and send message lah. Send message, right? So how you disable? If you can do individually on interface by interface basis, right? You go into the config into the interface and then type spanning tree BPDU guard enable, or you can do by default. By default, that means then after this you still need to go to individual port connecting to other infrastructure device like switch and routers and disable it. Okay, so because you can do whichever you feel that is more secure, right? But you have to, as administrator, to do the necessary. So if you want to set globally in config terminal, right? And then just type in spanning tree port fast BPDU guard default. Okay, all access port, right? Okay. Right. So here is what it looks like if you type it out now, right? And then this is the verification part. Show spanning tree summary, and it shows there, right? Again, same thing. Okay, any question?
No.
No.
Straightforward, can? All right. So I'll stop here because after that is the module practicing quiz. Then you should do. You should try to do the MCQ questions like the chapter exam, right? So I think tomorrow we're going to do the practical on this lah, right? The switch port, well the switch security configuration. Right. So let me stop here. Stop the recording first. Okay. Okay, so today's tutorial, okay, is tutorial 9. It's already got link there, right? You can go for a quick break, 5 to 10 minutes. When you had your break, come and do the tutorial 9. All right, so we'll switch our meet to the tutorial meet. Is that okay? I'll meet you guys there.
Okay.
All right. Well, welcome to tutorial, everyone. You can start doing the tutorial after after you take 5 minutes break or 5 to 10 minutes break, something like that. Okay. All right.
Okay.
Very good. One more, Calvin. Yes. I think that should be the solution. Yeah. The error configuration. Yes, wrong interface used. Okay. The interface used was fast Ethernet, right? It's supposed to be gigabit Ethernet. So you guys managed to find all that. Yeah. So the novels2 command is actually missing, right? The command by novel is missing. So yes, should have these two. And yes, not shut down, because shutdown, if you put protect, then can send a syslog message. That's correct also, right? So wrong interface. And for Fairer, yes, it's the requirement was 5 rather than 6, so that's correct as well. Yeah. So, and yes, the rest okay. So for your exam, if you get any questions like this, okay, if yeah, do try to write using your own word. Okay, it's okay as long as the meaning or the excuse me, the meaning of the sentence is the same, right? You can use your own words. Of course, you have to use the same keywords lah, like BP UGA, port files, right? Um, I know sometimes it's difficult to rewrite it your own words, but try lah, yeah, because if it's exactly the same, your marks will be cut, all right? And worst case scenario, it will be deemed as plagiarism. Okay, so just remember that for the theory questions, okay, during the exam FOA, they're quite strict lah. All right. Okay, so complete already our tutorial. All right, so you can use the remaining time to maybe do some revision, or maybe you can try the NetAcad MCQ question. Right, you can log into NetAcad and try the chapter exam. You can have up to 10 tries lah, right? I believe you can also stop and then resume later. Not sure about that one. Last time can, but now you guys can try lah. But do try the NetACAD questions, right? It's MCQ and it basically help you to see whether your information retention is okay or not lah, right? If you remember the theory part, right? Okay, so either that or you can also do some revision on the practical, or you can do your practical. Those you haven't finished, you can the remaining time still have about half an hour, kan? So half an hour you can do your practical questions. Those you haven't complete. Is that okay?
So how to access the NetACAD exam?
Yeah, just log in. After you log in, you can go for chapter exam.
Chapter exam. This one.
Right. So let me see. Now this is the topic already. Go back. It's not there. So go to. You should be able to see. Can you scroll down a bit? This is Introduction to Packet Tracer. So not this one. You have to go for the computer networks. Select the computer networks. The other one, yeah, that one. When I go down there, you can see the let me see, that's one is practice. Yeah, you can see there modules 10. You can try, if you want to try security first, you can yeah, that one, click on it.
This one.
Whenever it says exam, right?
This one.
Yeah. So any of the top module topic with exam, like assessment, right? Just use the newer one. If you have installed the newer one, right? Okay, so continue. Okay.
This one involve packet tracer.
Yeah, some question, a few questions lah. Not maybe one or two questions will be asking you on packet tracer, but not, you don't have to do the packet tracer. You just basically they give you the packet tracer, and then you answer based on the packet tracer, and then you choose A, B, C, D based on the packet tracer. Okay, so it will run your packet tracer if you've already installed. Okay, it's ready, can begin assessment. Yeah, and you can continue. So don't click submit. Submit means submit already. So click next on the left to go to the next question, right? Yeah, and then go back. Okay. Some students they accidentally click on the right hand most submit and then finish.
Okay.
Okay. All right. Right. So Kelvin and Farah, you can also access. Already enable it for you guys. Access that one. You can try it up to 10 times lah. If you're not satisfied, you want to try again, right? And then try until you get maybe you get all correct. And okay. So also use it for revision lah. Very easy to use as revision.
Do which one? There's so many. There's a lot of the exam one.
Yeah. It's you
do all the exam.
Yes, the ones for your. This one is for your revision. Okay. The final exam. The final exam is the one that your marks will be counted. Not counted for a course, but for the certificate from Cisco. The final exam is the one that will get you that cert. These ones are for practice.
No need to, don't select.
Sorry for the.
Yeah, this chapter module exam is for your practice. Okay. At the week 7 weekend, I will enable the final exam. Okay. That final
Oh.
exam, yeah, you can do within the weekend, anytime during the weekend. All right.
Oh.
And for that one, you can, if you when you pass it, I think that you have 3 tries lah, 3 tries. And then if you pass it, then you can get the Cisco cert. Okay, the final exam. Okay, but it's got no marks for our course. Okay, our course marks is basically the test and the SBA plus the examination at the end. Right, but if just like the FCN before, you can get the Cisco cert by doing the final exam. Right, the module chapter exam is for you to practice. Okay, and then it's depend on which chapter you want to practice on question. Is that okay, Noel and Kelvin and Farah?
Okay.
All right. Try to find some time where you can do it lah, right? But for me, you can use it also as revision lah for the exam. Okay, because it will ask you questions that helps you to revise back, right? What you have learned. Okay. Now, either you want to do that now for the remaining time, or you want to do the packet trace, up to you lah. Huh?
Okay.
Okay. Right. Don't forget at later at 5 o'clock, we have the dry run for the SPA.
Okay.